So in the last few videos, we talked about work and energy a lot, but our section is called Work, Energy, and Power. And so let's spend a video sort of talking about defining power. And before we actually start defining it, I would like to present a sort of problem to you. So let's talk about squatting again, since we already started talking about that. We already kind of worked out how to draw that picture. Let's say I'm squatting some weight. Let's say this weight is let's say it's 5,000 newtons. And let's say I'm lifting it up exactly 1 meter. And then it takes me 5 seconds to lift it. And then let's say another person, let's say Greg, super competitive over here, he's lifting the exact same weight. So he's also squatting 5,000 newtons. So let's go ahead and draw his barbell. And let's label that also as 5,000 newtons. And he's also lifting it 1 meter. But let's say it only takes him 1 second to lift this up. My question to you is, what is the difference in what we are doing? And so you might say, well, clearly he's doing more work than you because he's going so much faster. But my question to you is he? If you look, work equals force times distance. And so the work I'm doing, we could say, well, let's go ahead and write a question mark for ourselves. We'll say that that is, well, 5,000 newtons multiplied. So let's add some parentheses here. But multiplied by, well, 1 meter. That's super simple. Our work, the work that I'm doing, or the energy I'm spending, another way to put it, is 5,000 times 1 is just 5,000 joules. And if you look over here what Greg's doing, well, his work is the exact same, isn't it? It's still 5,000 newtons times his distance, which is just 1 meter, so there's no difference in the work that we're doing. 5,000 times 1 is still just a total work of 5,000 joules. And so there's no difference in the work that we're doing, so you might be asking yourselves, well, what is the difference? And the difference is the time that it's taking us to do it. But time doesn't affect your work. Work is just force and distance. Time only affects what we call power. And the definition of power is the rate of energy over time. And of course, since energy and work are the same thing, another way to write this is the rate of work over time. When I say over time, what I literally mean is you take your work or you take your energy and put it over time. So we put, we'll say work divided by time, or we could say energy divided by time. Both are acceptable because both are the exact same thing. So with that, let's go ahead and figure out what the difference in our power is. Well, the formula for power is just our work divided by our time, or our energy expended divided by our time. And we just figured out our work is 5,000 joules. And the time that it took me to lift it was 5 seconds. So that's not too hard to figure out. We get power equals 5,000 divided by 5 is simply 1,000, and then joules divided by seconds is just joules per second. Or we can write it as power equals 1,000 watts. Because watts is the official unit for power. Joules per second is also acceptable. They are the same thing, but watts is technically the correct unit. So then we go ahead and figure out what the power is over here. Well, it's the exact same thing, right? It's still just 5,000 on top, or at least it's the same formula, I should say. It's still just 5,000 joules on top. But this time the difference is we put only 1 second on bottom, and 5,000 divided by 1 is even easier to figure out. That's just anything divided by 1 is itself. So we get 5,000 divided by 1 is just 5,000. Joules divided by seconds is joules per second. Or, of course, we could just write 5,000 watts. That's how you solve for power.